So we're about to start into the OO part of C#. Somebody asked a really interesting question on the tutorial forum. Somebody asked, you know, if strings in C# are so great, why did we spend 3 weeks doing strings in C? Can anybody answer that question? Does it seem rather pointless that we spent all that time learning about strings in C?
No.
Can anybody answer why did we spend so long working on strings in C the hard way? What's that? Well, it isn't really, because C# has got a completely different way of doing a lot of the things that we learned in C. But it's important because not every program is written in C#. Alright? In fact, you know, C is one of the most popular programming languages ever invented. There's probably more lines of code in C than there is all the other programming languages out there. So the chances of you just using these nice, friendly OO languages like C# and Java and even C++ for your entire career are probably pretty slim. You're going to have to program in C, I would think, at some stage in your career. So it's important to understand all of the issues. The other thing as well is C# makes everything a bit easy for you, but it's important to understand how things work underneath. And it does help you to become a better computer scientist if you understand things like pointers and memory and how arrays are actually organized and stuff at a lower level. So that's why we spent so long working on strings in C. Anyway, so what we'll do today is I want to run through a lot of the terminology that we're going to make use of over the next 4 or 5 weeks. And so I'm going to put loads of definitions up on the board, and then for the second part of the class we'll write our first class in C#. Alright? So everybody, you need to take out a pen and write these definitions down so you have them. The first thing we have is this idea of a class. Alright? Then we have a thing called an object. And we also have another thing called, well, you know, another way of saying an object is an instance, I-N-S-T-A-N-C-E, an instance of a class. Then we have this idea of fields. We have methods. We have things called constructors, S-T-R-U-C-T-O-R-S, and destructors. We have a thing called properties. We have things called delegates, D-L-E-G-A-T-E. We then have this concept of inheritance and polymorphism. We have a thing called an interface. And we have abstract classes. And we also have virtual functions and override functions. So probably a couple more things will occur to me as we're having this little chat about the sort of concepts of C#, right? But if I think of them, I'll write them up on the board. But for now, I want to give you a definition for each one of these terms so that if you're ever asked it in an exam or in an interview, you're able to give the right answer. So the first thing, a class. Can anybody tell me what a class is? A type. Great. A class is a type. Alright, so a class is an int, or in C# string, or car. So it's a type. Alright, so that's the number one to say. A class is a type. The other thing to say about a class is a template for an instance of an object. So it's a template. So by that I mean it describes the characteristics of objects in software. So that's a definition for a class. You can say that it's a template for an object. Right, so in the real world we're used to thinking of classes and things all the time. So in my head I have this idea of what an iPhone is, right? I know that an iPhone has a screen. You can press things on the screen, you can connect to your email, you can do various things with your iPhone, synchronize. But that's in my head, that's the concept of an iPhone, right? But some of you actually have iPhones, real iPhones. That's the difference between, no, you don't have one, right? But what have you got? Okay, right? Well, anyway, just disambiguating between the idea of what something is and the actual instance. The instance is the iPhone itself, or the HTC, or whatever. And then the concept or the type is the thing in your head. So that's the difference between a class and an object, or an instance of an object. So what's an object? It's an instance of a class, right? So that's the first thing we can say. That's a class, and an object is a concrete class, if you want to say it like that. C-or-E-T-E class. An object is also referred to as an instance of a class. It's an instance of a class, so it's something that's actually real, that there's a memory allocated to. Otherwise, you just have a template. Some books will refer to instances of classes, some books refer to objects. And those two terms, they mean the same thing, okay? So sometimes you hear the cat object, or the dog object, or the player object, or sometimes you'll hear it referred to as the player instance, or the cat instance, whatever. Those two concepts mean the same thing. Alright, so it's a concrete class. In the same way that you can go int I, when you create an instance of a class, I is the instance and int is the class. Alright? But we can make a class of things. So what are fields? Anyone want to have a guess of what a field is? Have you ever come across that term before? You guys are studying databases this year, are you? So have you come across that idea of a field? Yep. So what's a field in a database?
When you fill in the info?
Exactly. So it's actually a piece of data. Alright, so a field is a data member of a class. So an example of a field would be if you were creating a dog class, then you might say that that dog has, what have dogs got? Nails? Huh? Tails, right, okay. I'm thinking more of...
Colour, breed.
Yeah, colour, breed, its name, its age. So the data or the information that you need to store about something, that's a field. What you're talking about when you're saying a dog has a tail is more a thing called aggregation. So in other words, this is saying a dog, which is an object, is made up of other objects, right? Like a tail object and a leg object and stuff. That's kind of a different concept, right? But for now, we're looking at the actual data. In other words, the variables that we need to keep track of for every instance, and that's what a field is. What about methods? Methods are functions, okay? So they're the C# equivalent of what we call a function. Methods are slightly different to functions. Why is a method different to a function? In a function in C, the information that the function acts on, where does it get it from? You? Go on. If you want a function to act on some information, where does it get the information from? Come on. Yeah, where does it get it? Where does it get it from? Parameters. So you pass parameters into a function. Alright, with a method on the other hand, the method can act upon the object itself. So if you have a method, the one we're going to do is the dog example, right? So the dog might want to, what can dogs do? Bark. Dogs can bark, right? So the dog can access its own fields as well. Alright, we'll do an example of this. A method is connected to an object, so it's not a standalone thing anymore. A method is something that an object can do. In fact, that's a good definition for it. A method is a function, in other words, something an object can do. Alright, so a dog can bark, a dog can fetch, dogs can do lots of other things. Dog can eat, right? A dog can't drive, so drive is not a method on the dog class. You follow? Does that make sense? So it's the methods that are associated with the class. Constructors, what's a constructor? Just have a guess.
It's for creating objects out of class.
There you go. Alright, so what is it? I mean, what's the relationship? Is it something that we've already looked at?
Yes.
What is it? The constructor is it's a method. Alright, so a constructor is just a method. And it's a special method, right? It's a special method that gets called when the object is created. Alright, so the constructor. It's just a method that gets called when the object is created. Alright, so a method that gets called when the object is created is called a constructor. Can you have more than one constructor? Yeah. Yes, definitely. How would you have more than one constructor? You overload them, alright? Which leads us to another concept called overloading. Just throw out the answers. Don't be, we'll just try and discover this rather than, I'm not going to tell you all. Just throw out what you think. I want you to think about these concepts as well. Overloading is the idea that you have the same method with different parameters. So that's what overloading means. And you can do it in C as well. You can have the same function that takes different parameters, and then the compiler works out which is the right one to call, depending on what parameters you pass in. So overloading is the same thing in C#. You can have the same method with different parameter lists, and the compiler decides which one is the right one to call. Depending on if you pass a string, we'll call the one with the string. If you pass two ints, it calls the constructor that takes two integers. So we'll make overloaded constructors, and you can have multiple constructors with different parameters. So if a constructor is for creating an object, a destructor is for destroying the object. So when the object goes out of scope, its destructors it gets called. So C# and Java and C++, C# and C++ do destructors. Java doesn't have destructors. There's no concept of a destructor. And in C#, destructors are hardly ever used. Why are destructors hardly ever used in C#? What do you think? Because it's done automatically, right? There's a thing called garbage collecting, which is part of the .NET framework and the Mono framework, right? And that automatically frees up the memory when you're not using anything anymore. So there's no. In C, we would have used what to free memory? What would we use to free memory? Can you remember? Can you remember? To allocate memory, we use alloc, and to free memory, we use free. There's no equivalent in C# of free, okay? Because there's this thing called the garbage collector, which is a low priority process that runs and constantly is analyzing your program to see if you're not using a variable anymore, it deallocates the memory. So, properties. Any idea what a property is? You mightn't get this one. What's the difference between a property and a field? Anyone, any ideas? They sound like similar kind of things, don't they? So this is a thing you won't really get until we do a demo, but a property is a way of getting access to a field via a method. And that's the definition for it. And I'll show you an example. So the kind of classic example, or maybe a good example for this is to consider something like a rectangle. A rectangle might have a length and it might have a breadth, and these are going to be fields. The area of the rectangle, you don't need to store it, you just calculate it by saying the length multiplied by the breadth. So that's an example of a property. You're going to call a method to calculate some value on the object, but it's not actually stored in the object, okay? And there's loads of reasons why you might want to use these, but we'll get a little bit further. A delegate. Anyone any idea what a delegate is? Definition-wise, I better rub some space out on the board here. Maybe if I give you an example of where you would use one. You might imagine that you're developing a little program, and the program has a button in it, and you want something to happen when you click the button. How do you tell the button, I want to do this, when you get clicked? You do it by means of a delegate. So you pass a method to the button, you say call this method. So it's basically passing a method as a parameter is when you would use it. Can you see why you might want to do something like that? You might want some little bit of your program to run when you click a button. And how you do that is you say to the button, here's the delegate. Call this method when you get clicked. And then you can specify what the method is, and you can put code inside the method as a parameter. So these are all concepts, and we're not going to do them all today. We'll do these over the next few weeks. Inheritance. Anyone have any ideas what inheritance means?
Choice less inheritance on.
Yep. Very good. So inheritance is the idea that you can create hierarchies of related types. By that I mean you might, for example, say that if we were doing our dog class again, we might have a living thing base class. The living thing can breathe, right? The living thing maybe has got an age, and then a dog inherits everything that a living thing has. So everything like breathing and having an age, the dog gets because it inherits from. You understand? And a cat can also inherit from. So you've got different classifications of things, and there's like a hierarchy. That's what inheritance. Does that make sense? So that's how you group things together. It's called inheritance, okay? Polymorphism. You know, when we talk about OO, the three pillars of OO, encapsulation, inheritance, and polymorphism. Polymorphism is a cool one. Once you get it, you'll see how useful it is. And it's particularly useful in making games. But in fact, there's loads of examples where polymorphism is really a great solution to the problem. Anyone on any ideas? Well, you can probably figure out from the name. What's poly mean? Many. And morph? Change. Many changes. So the kind of technical definition for polymorphism is, I'm going to write this up, and you won't really understand it until we do an example. The ability for an object to change its type at runtime. So again, that's the definition, but when we do it, which won't be for another few weeks, you'll see how useful it is. So for example, you can have your living thing, you can have a subclass called dog, you can have a subclass called cat, you can refer to the dog as a living thing. That's the whole idea of it. And the dog can be any of its parent classes can be referred to. So again, you won't understand it until we do it, but I'm just giving you the definition for now. An interface. What's an interface? Any ideas?
How the user reacts to it.
Sure, that's what we call a user interface, right? A user interface, an interface between classes. Again, it's one of these things you won't read until we do an example of it. But it's a contract. The technical definition for an interface is a contract between two classes. So one class says, you create an interface which is the contract. Okay, so you might say, for example, let me think of a good example here. Okay, do the bank account thing, you know. You might decide that all bank accounts have a deposit and withdraw method, and then there are specific bank accounts with different ways of doing deposits and withdrawals, but I just refer to a bank account. I don't care how the deposit and withdrawal thing works, because I have a contract with me and every other bank account, and so that's the contract. The contract is the interface. Interface is literally nothing more than a set of methods the class must implement. You follow? Make sense at all? That's it. You know, it's a contract. Another one would be, we'll say, you know, if you pick a number of people that speak different languages, and you decide that you want to try and, I don't know, I can't think of a good example off the top of my head. I'll have to think of a better. It's a contract between two people, an agreement that certain methods have to be implemented. It's a class thing. But don't worry, we'll get to it and you'll see. Okay? But I'm introducing you to all these concepts because we're going to come back to them, you know, over the next number of weeks. An abstract class, this is getting kind of a little bit more obscure, and it's going to be hard for you to think of an example, or to sort of get connected to what this means until you see an example of it. Anyone want to throw out what they think an abstract class is? What does abstract mean? What's the word mean?
Virtual.
What's that?
Virtual class.
A what? A virtual class.
Yeah.
Yes, that's exactly it. In C++, we would call it a class that implements a pure virtual function. The definition for an abstract class is a class that can't be instantiated. I'll just make a couple of notes on abstract classes, and then we'll make an actual class. Abstract. Number one, can't be instantiated. If you want to instantiate it, how would you instantiate an abstract class if you can't instantiate it?
What does instantiate?
Oh, instantiate means create an object from. Yeah, create an object from.
Same as
An instance, yeah. So, in other words, to take the class and make one. You know, when you go into I, you're making an integer. So it can't be instantiated. That's a good question. And also, the only way you can instantiate it is you must create a subclass. And there are very few real-world examples. I don't know, I can't think of any good real-world examples. The example that I always use is in a game engine, because I do lots of games programming. Sometimes you might say in your game engine, alright, if you pick a 2D game engine, all the objects that I'm drawing on the screen all have a position and they all can be updated and drawn. So I might make that an abstract base class. And then, you know, it doesn't make sense to have a game entity. You've got to have subclasses of the game entity. So you have to have the player and the enemy and the bullets. So they're all the subclasses which are not abstract, and then the base class is abstract. So again, this is the kind of thing you need an example of. This is all the terminology. Right, your homework. And I'm going to do an example of this class, but your homework before I go any further. Chapter 4 of Rob Moyle's yellow book describes all of these concepts in great detail. And you'll read the entire chapter probably in an hour. But it goes into way more detail than we're going to do in this week or next week. This is basically our whole first semester. Most of our first semester is chapter 4 of Rob Moyle's yellow book. So if you find yourself not understanding any of these examples, go and read chapter 4 in Rob Moyle's yellow book. Alright? And it takes you through every single concept we've discussed on the board with lots of concrete examples. In fact, the one that Rob Moyles uses is bank account. Alright? And he gives examples of this very complex, complete banking system developed using all of these concepts. Is that alright? Will we go and make our first class? Everybody excited? If you have your laptop there, you can follow along, okay? I'm going to go and make my first class, and we'll do some real examples of these concepts. Laptop one. That's right. Here. Alright, I think we should turn the light off. What do you think? Is it a bit hard to read? Oh, that's very dark now.
Probably just your one, right?
Huh?
The switch just to turn off yours.
Oh, I don't know. I think that's the only one.
No, there's a switch just there.
Where? Oh, just here. Alright, let me start it up and see if it's readable, okay? I'll zoom in. And if you're down the back and you can't see, you know, just come up, and of course you can always watch it on YouTube later. So, anyway, I'm going to create a new project. Console application in OOP. We stick to console application in Visual Studio, right? So, okay, here's my kind of shell of a program. Alright, so we've already got a lot of the concepts which we've already discussed, yeah? So, there's the keyword class. So this is creating a class called a program class. Alright, this is how you do it in C#. And here's a method called main, which is taking some parameters. And one thing I forgot to put up was this idea of the static. And this is really important, and everybody gets this wrong when I ask it in the exam. People typically say, when I say, what does the word static mean in C#? People say, it means that it can't change. Right? That's not the case. The static just means that this method applies to the class program rather than an instance of the class. And it means you can call it without having to create an instance. So in this example here, it makes an awful lot of sense, right? Because if you think about it, right? In order to call a method on an instance of a class, you have to create one. So you have to have an object created to call a method on it. But when your program starts, there's no objects created. Something has to create the first object. So you need to be able to call a method without there being an instance created. And that's why it's called static. It means that you can call it without there needing to be an instance. If you want a kind of a real-world example of this, I think the one that Rob Moyles uses, and a lot of C++ and C# books use, is the bank account. Alright? Bank accounts, each bank account has got a bank balance. Yeah? But maybe they all share the same interest rate. So if you change the interest rate, you want it to change all over the place. You don't just want to set the interest rate on each individual one, and that's why you might make that a static. If it applies to all instances, right? That's what a static is. So this is an example of being able to call a method on this class without having to create an instance first of all. And that's what static means. Okay, so it doesn't do anything. I'm going to create my first class. So some rules about creating classes. First thing is, we can just click add new item here. I want to add a class, and then I'm going to give my class a name, and the name I'm going to give this class is just dog. Okay, like that. And I'm going to click on add. See what happens here. Alright. So there's the template really for a new class. Now a couple of very important things. Number one, it's not essential in C# to put every class into a separate file, but it's the recommended way. So every time you create a new class, you put it into a separate file. So write that down as a note. The second important thing about making a class is the name of the file should be the same name as the class. So if our class is called dog, the name of the file should be dog.cs. That's rule number 2. Rule number 3. Whenever I'm making a class, I always use an uppercase letter for the class name. So if I'm making a dog class, it's uppercase D-O-G. Alright, if I'm making a person class, it's uppercase P-R-S-O-N. Alright, so there's the 3 rules for naming classes. Number 1, should be in the file, which is the same name as the class. Number 2, you use an uppercase letter. What was the 3rd rule?
Using capital.
New file, needing capital. There's 3 of them.
Same as the file.
Same as the file. Okay, there's 3 rules. Right. So the next thing then, just even looking at this, there's another thing here which we haven't even spoken about. This is namespace thing here. So I want you to just get this, don't be thinking this is anything complicated. A namespace, in the same way that a class is a collection of fields and methods, a namespace is just a collection of classes. Right? And it's a logical collection of classes. It just means that you can, if you have lots of dog classes, for example, if you were using a third-party library and it also had a dog class, a namespace allows you to disambiguate between different classes with the same name. And again, you should probably write that down. It's nothing complicated. It's just a way of disambiguating. Potentially, if you've got the same class with the same name, you can disambiguate them by putting them into different namespaces. Alright, so with dog, it's unlikely we're going to have a dog class, but you never know. So they make you in C# put everything into a namespace. And when you create your new application, it makes a namespace which is the same name as the program that you're actually making. And if you notice, console application 6 and in here program.cs, they're both in the same namespace. Alright, so let's put them into the same namespace. Alright, let's make some stuff in this dog class. The first thing I'm going to do is I'm going to put the word public here. Alright, whenever you're making a new class, I recommend that you always put the word public in here. There are several other options here, but nobody ever uses them. Alright, 99% of the time you want to make it public. Public just means that it can be used by other classes outside the namespace. But forget about it, don't even think about it, just put the word public in there. Alright, now we're going to make some fields. So what do dogs have? What information do we have about a dog that we need to store? Name, breed. Okay, let's do name and breed first of all. What type should we make those? Strings, alright. And just for now, I'm also going to make this public, right? So public string name.
Is that the default, Brian, if you leave out public? Yeah.
No, I think that the default is protected, I think.
Is it?
Yeah. It means you can't access it outside the namespace, but I'm not 100% sure. The default is private, is it? We can look it up, right? We'll look it up in a minute. And in fact, we can do a little experiment to see what it is, right? But for today, we're going to make them public. What public means, and we'll get to this next week, what public means basically is that methods outside of this can get access to that data. That's what it means, right? So we've got public string name, public string breed. Just so we don't have all strings, let's put an int in there. Let's put the age. Public int age. All right. What do dogs do? Dogs bark, right? So let's put a method on it called bark. Public void bark. All right. Now, a couple of things to note here. First of all of these fields, we can put them with a lowercase letter here. All right. And that's the convention in C#, is that your fields always start with a lowercase. It's not enforced. And your program will compile just fine even if you don't do it like that. All your methods should start with an uppercase character. In Java, they use a lowercase character for the methods as well, but in C#, the convention is to use an uppercase character to start the method name. So, we have name, breed, age, these are the fields, and then we have a method called bark. And what do dogs do when they bark? What do dogs say when they bark? Everybody say it, 1, 2, 3.
Whoa.
That's better, okay. Console.writeLine. Is that the way it's spelled wolf or W? Exclamation mark. Woof woof. Okay, so the dog says woof woof when it barks. So this is our template for what a class looks like. Class has got all the fields listed up at the top, and then it has all the methods listed here. Now, we now have 2 bits of our program in separate files, and we need to link them. So the way we link these 2 things up together is by creating an instance of the dog, because this is just a class. This is basically saying all dogs have an age, have a name, have a breed, and all dogs can bark. Right? We haven't actually created any dogs yet. What makes a dog? Huh? I guess another dog really makes a dog, okay? But in this example here, our program is going to make a dog, right? And this is how you create an instance. Dog, which is the type, right? Who has a dog here? Who has a dog? Anyone have a dog? Put up your hand. Nobody has a dog? Come on, what's your dog called? Dory. D-O-R. Okay, dog Dory. Now, here's the magic in C#. To instantiate a new dog, you use the word new. So you go dog Dory equals new dog. I have now created an instance of the dog class. Dog, D-O-G, uppercase, is the type. And then D-O-R-I, Dory, is the instance. It's the variable which contains all the information about that particular dog. So, you remember we did structs in C? Yep. So we can do something similar to get access to the fields, which are part of the Dory instance. And there you go. Even when you do dot there, Visual Studio is helping you. It's saying, hey look, this dog has an age, and you use dot to get access. So how old is your dog? 3. So Dory is 3. Dory.name is going to be equals to the string Dory, and then Dory dot breed. What's the breed of Dory? Mongrel. M-O-N-G-R-E-L. It's a mongrel. And you can also go Dory dot bark. Alright, so that's our first example of a class, creating an instance of the class. There's a couple of interesting things here which I'm just going to point out, and maybe you've even noticed them already. First thing here is, I go dog Dory equals new dog, open brackets, close brackets. So what do we normally use open and close brackets for? Yeah, passing parameters to what though? To what though? To a function in C or to a method in C#. So this is actually calling a dog function or method, and then open close brackets means I'm not passing any parameters in. This is an example of a constructor. So if you don't specify a constructor, in other words a method for creating an instance of a class, C# makes one for you by default. And this is an example of what's called a default constructor. A constructor which takes no arguments. And it doesn't do anything. So if you don't make your own one, C# gives you one for free. The next thing is you go Dory dot to get access to the fields which are part of the object. Is everybody happy with that? Now, I'm going to do something here, and you might get this already, and you might think this is really trivial, but this is really important. Look at this. My dog is called Misty, right? Equals new dog. So you can now go Misty.age. So Misty is 3. Misty.breed is a King Charles. Misty.name equals Misty. Alright, and I can go Dory.bark and Misty.bark. Alright. So this is the thing, which I don't know, maybe this is obvious too, but I just want to make sure that everybody's completely clear about this idea. I have created one class called dog. Alright? And that one class has got 3 variables in it. It has age, name, and breed. So what I'm basically saying is that every dog has got its own name, every dog has got its own age, and every dog has got its own breed. So when I look at this here, this is Misty, and the other dog is Dory. I have now created 2 separate instances. So looking at the fields that's in the dog, there's now 2 of them. Alright, there's one for Misty, and there's one for Dory. So there's 2 separate versions of that dog, with each has its own set of 3 variables. Does everybody kind of get that concept? Was that obvious? Good. It's like when you make a struct and you create different instances of the struct, right? Or you make different variables from the struct. So I'm going to customize this slightly, just to really emphasize that idea that now there's 2 of these dogs, and that these variables are duplicated for each instance. So you can do this. Watch this. Name says woof woof. Okay. First thing, where is it getting name from?
From the field.
It's getting it from the field. Alright? You might look at this and say, well, there's no name declared here. There's no local variable called name. There's no parameter called name. Okay? So every method can make use of the fields. Now, the next thing is which name gets printed out here when you call this method.
Whichever dog is
It depends on which dog is actually having the method called on it. So if it's Misty, the dog, then Misty is the name, or Misty is the value that's held in that. If it's Dory, then it's Dory. Alright, so you might say, well, why isn't this, well, the variable there is name. How can it have 2 different values? It's because it's 2 different instances of the same object. Does everybody kind of get that whole kind of concept? What do you think? It's your chance to ask any questions if you're not 100% sure about any of the stuff we've just done. Never mind if you're not 100% sure. Will I run the program and see what happens? Let's run it and see what happens. I think you're going to be really impressed. Loads of cool things are going to happen. Let's put a console.read line at the end of the program. Get it to pause. Alright, and I'm going to run the program. Everybody excited? You don't sound it. There we go, look at that. Dory says woof woof, Misty says woof woof. So I've created 2 separate instances of the dog class, and I've called a method on the dog class. Everybody happy so far? Should we go on a tiny bit further? Let's do one more thing today, okay? So, I previously mentioned this idea of a constructor. What is a constructor? It's a method that gets called when you create the object. So, here's the rules for a constructor, okay? You should write these down. Rule number 1 for a constructor. In fact, you can probably figure these out yourself. Does a constructor return anything? What would you think? No is the answer. So there's no return type for a constructor. That's rule number 1, okay? Rule number 2, the name of the constructor is the same name as the class, alright? Rule number 3 for constructors, can you have more than one constructor? Yes. And how do you have more than one? If they take different parameters, Okay, so there's the 3 rules for constructors. Rule number 1, no return value. So we don't put void or int or anything like that, it's just public and then the constructor. Rule number 2, it's the same name. And rule number 3, you can have as many as you like so long as they all take different parameters. So there's my default one. I'm just going to change the default one because C# gives you one anyway. But you can just go age equals 0. So I'm initializing this. Name equals the empty string and age equals the empty string. So that's a good default constructor. Alright, so it's a constructor that just basically initializes it to have nothing. Now if you don't put your own default constructor in C#, not age, sorry, that should be read. If you don't put your own one in there, C# gives you one. Alright, but it doesn't put any body in it, so it doesn't do anything. It's an empty constructor. Let's make a better constructor. Public dog. We'll make one now that initializes age, name, and breed. Int age. String name. String breed. Now I have a slight problem here, don't I? What I want to do in this constructor is I want to take this age parameter and I want to assign the field to be whatever's passed in the constructor. And I want to take the name parameter and I want to change this name to be whatever the value of this name parameter is here. And then similarly, this breed, I want to take this and I want to assign this to be its value. Can you see what the problem we have though? What's the problem? Oh yeah. What's that going to do though? Nothing. Can you see what the problem is? I mean, what I really like to do is something like this. Age is equals to age. Uh-oh, that isn't going to do anything. Do you see what I'm trying to do? What I'm trying to do is take this one and assign it to be take this and overwrite this guy's value, the one that's passed into the parameter. So how would we solve that? What's the obvious way to solve it? Change the names of parameters, right? Here's a simple way to solve it. You can go, and this is kind of very typical, a lot of iOS developers do this, they just go age equals underscore age, like that. And then they're different. You know, just saying this is a different name to this one. You know, this is taking the age and taking it from the parameter. The C# way of doing this, and this is the Java way and the C++ way as well, is to do this instead. And we will come back to this in the next class, right? This dot age equals age. This dot name equals name. This breed equals breed. That's kind of more the C# way of doing it. Alright? So this is another keyword in C#, and what this means is the current guy. If we're talking about Misty, then this is Misty. If we're talking about Dory, then this is Dory. It's the current one. Right? It's a way of disambiguating between the age that's passed in a parameter and the things which are actually fields, which are part of the object itself. Does that make sense?
The current one.
It's the current instance or the current object. So the thing is, when you go this.age inside this method, because it's part of the class, it means whatever one I'm currently dealing with. In the same way that down there, if I just use name by itself, it's the field name. You could equally replace that with this.name, and it would mean the same thing. This.name. So that this thing is used to disambiguate. To disambiguate. In other words, in this example here, there's no parameter. So when I refer to this.name and name, it's the same one. But up here, age could be either the parameter or the field. So when you do this.age, it's saying the current object age. And is that alright? Let's do an example of calling that constructor and then we'll finish, right? So we need another dog. Who else has a dog? Huh? Shane, what's your dog called?
Mr. T.
Mr. T. What's the way I'm going to call this here? I'm going to call it with, in fact, you notice what's after happening here. Look at this. Visual Studio is after saying, hey, there's 2 constructors for this guy. Which one do you want to call? That one that takes no parameters, or that one that takes age, name, and breed? So it's helping you as you code. So how old is Mr. T?
Age 7.
And his name is Mr. T, the string. And his breed?
King Charles.
Ah, King Charles, lovely dogs. Is he a fat King Charles?
Yeah, he is.
They do tend to get fat. I mean, I was in St. Anne's Park with a friend of mine yesterday, and she had 3 King Charles, and they were all fat. They tend to get, because they got little small legs, you know? So, I think they're really cute dogs as well. They just want to be picked up and cuddled all the time. So people tend to think, oh, they're just, you know, they like lap dogs kind of thing. But they're like all dogs. All dogs like to be out and getting plenty of exercise. Even a King, I bring my King Charles running. You know, I bring her in the lead, I'll do 2 or 3 laps at Fairview Park, come back to 2-3 mile run. Little legs going like this the whole time. Really cute. But she loves it. She's a runner. Anyway, look at that. I've called the constructor, passed in those pre-parameters, and now I can go Mr. T. Bark. And before I even run the program, when I call Mr. T. Bark, what's going to get printed out? Mr. T says woof woof. Alright, don't forget that. So we'll make use of the name. In fact, what we'll do the next day is I'll set a breakpoint here and you can see it call like this. Alright? So that's your introduction to classes in C#. After a while, you'll wonder have you ever programmed in C before? Because everything, once you start thinking about it, it's a great way of representing things, you know, like buttons, and text fields, and labels, and screens, and lots of things. They're all classes. They make a lot more sense when you're alrighty? Okay, let's leave it at that.